Okay, so we're talking section 1.2 now, guys, graphing quadratic functions in vertex or intercept form. Okay, we are going to focus today on vertex form. So what you see in this box here, okay, the graph of the vertex form of y equals a parentheses x minus h squared plus k. So that's what vertex form looks like right there. Y equals a parentheses x minus h squared plus k. All right, so for your notes at home, that's what vertex form looks like. Okay, now a couple things about that form. First off, a. We talked about a in standard form. The function and the purpose of the value of a does not change. That stays exactly the same. If you notice at the bottom of this box, they talk a little bit about a. If a is greater than 0 or a positive number, our parabola is still going to open up. If a is less than 0 or a negative number, it's still going to open down. All right, and the rule of the bigger the a value, the skinnier the graph, the smaller the a value, okay, the wider the graph, that still holds true. So nothing changes about a. The form just looks a little bit different. So if I was to look at a parabola, okay, that looks something like this, all right, doesn't really matter what the equation is. That kind of looks like our parent function, maybe y equals x squared. Okay, it's definitely similar to it. Okay, this h and this k are just going to cause the graph to shift, okay, depending on what h and k are. So the graph is still going to look the same. It's just going to be shifted or translated into a new spot. So you might have that graph be shifted to the right. You might have that graph be shifted down and to the left. Okay, it all depends on what h and k are. The vertex of these graphs are going to be whatever number lands in the h position, comma, whatever number lands in the k position. So the vertex, guys, is going to be really easy to find. Okay, and since we know that the vertex is what creates the axis of symmetry, our axis of symmetry is going to be the x coordinate of the vertex, which doesn't change. Okay, so the axis of symmetry is going to be at x is equal to h. Okay, so there's obviously a couple differences, okay, but the execution of this is really not that bad. Okay, so let's jump right into examples here. Okay, so we're going to graph y is equal to -1/4 parentheses x plus 2 squared plus 5. Okay, the first and most important thing always, guys, is to find the vertex. And remember that the vertex is h comma k. So for this one, it's a little bit different because if I go back up, okay, remember the form looks like this. This is what vertex form looks like. In the form, there is a minus sign built in, okay? There's a minus sign built into the form. Down here, we have a positive. Because it's a positive, I have to take the opposite because we want that number, okay, or we want that sign to be a negative. So x plus 2, guys, that's actually the same thing as saying x minus a -2. So my h value is actually -2. So you guys just have to remember when it's positive, you actually take the opposite and you make it negative. Okay, so the x coordinate of my vertex is -2. The y coordinate of my vertex is whatever k is, in this case 5. So your vertex is 2 left, 1, 2, 3, 4, 5 up. There's my vertex. Okay, your axis of symmetry, okay, your axis of symmetry is the line going through that x coordinate. So x is equal to -2, which is this line right here. Okay, so there's our axis of symmetry. Okay, so we're still going to use that axis to our advantage when we talk about finding points. Okay, now let's go back to the equation, right? We have y is equal to negative 1 over 4, parentheses, x plus 2, whoop, little glitch there, x plus 2 squared plus 5. Okay, if you look at your a value, my a value is negative, so this graph is going to go down. My a value is also smaller than 1, so this is going to be a wide graph going down. Okay, now our next job is we are going to find other points, okay, on this graph, and we're going to use the axis of symmetry to help us. All right, so you're going to pick values of x, okay, to help you find other points, and then you're going to flip that point over the axis of symmetry. Okay, so if we were to pick two x values, I'm going to pick x is equal to 0, since that's a pretty easy one. And I'm also going to pick x is equal to 2. I'm picking 0 because 0 is typically an easy number to use. All right, and I'm picking 2 because I want to keep this an even number, because this fraction on the outside makes me a little bit nervous. But I think if I use an even number, I think that'll keep the numbers nice and neat for me. So let's see what happens. So when x is equal to 0, y is equal to negative 1/4, 0 plus 2 squared plus 5, which would equal negative 1/4, 0 plus 2 on the inside of parentheses is 2 squared plus 5, negative 1/4, 2 to the second power is 4 plus 5. These 4s would then cancel out, leaving me with negative 1 plus 5, which is a positive 4. So what that means, guys, is the point 0, 4 is on my graph. 0, 1, 2, 3, 4, right there. And then I can flip that point. This is 2 away from my axis. I can go 2 the other way and find another point, which is actually negative 4, 4. Let me label my vertex here, guys. That's negative 2, 5. So you can see what the graph is going to start to do. Okay, and then when x is equal to 2, y is equal to negative 1 over 4. Okay, 2 plus 2 squared plus 5, negative 1 over 4. 2 plus 2 on the inside gives me a 4 squared plus 5. I know I'm running out of room here, guys, so I'm going to skip around here where I got some space. Okay, negative 1 over 4 times 4 to the second power right there, that's 16, plus 5. Negative 1 over 4 is 16. Multiplying by 1 over 4 is the same thing as dividing by 4. So this is the same thing as really dividing by a negative 4. You can use your calculator for that. That's negative 4 plus 5, which is positive 1. So that means the point 2, 1 is going to be on my graph. 1, 2, 1. Okay, and that point is 1, 2, 3, 4 units away this way. So I'm going to go 1, 2, 3, 4 units away that way. And that looks like negative 6, 1. Okay, so now we got a real good idea of what's going on with my graph. So your U looks something like that, okay? A wide U heading down, okay? Hopefully you guys followed that. I'm going to do one more for you. So if we go down here, okay, I'm going to pick number 1, okay? So we're going to do number 1, okay? The vertex of number 1, again, the most important thing. Well, actually, even before I find my vertex, the a value in the front here, I got y is equal to, there's no a in front of the parentheses, so that's an invisible 1, x plus 2 squared minus 3. So the a value is 1. So it's positive, so it's going to go up, and it's exactly 1. So it's going to be just like our parent function. This isn't going to be any skinnier or wider than our normal parent function. The vertex of our graph, okay, h comma k, we just talked about it in the previous example, okay? If it's a positive, the h is actually going to be a negative, okay? Because a positive is the same thing as a minus minus. Remember, that minus is built in. So the x coordinate is negative 2, okay? the y coordinate, which is k, is -3. Okay, that's that point out here on the outside. So my vertex is 2 left, 1, 2, 3 down. Okay, so your axis of symmetry is x is equal to, you steal the x coordinate of the vertex, x equals -2. So my axis of symmetry goes right down here. Okay, and then I'm going to pick 2 more values of x. Now, being that I don't have a fraction in this problem, I don't need to be nervous about what values I pick for x. I just am going to stay away from obviously -2 because I already used -2. -2 is the vertex. So I'm still going to use 0. Okay, and then I'm also going to use 1. Okay, and then we're going to use those points to flip them over and make other points. So when x is equal to 0, I have 0 plus 2 squared minus 3, which would be 2 squared minus 3, which would be 4 minus 3, which would be 1. So the point 0, 1 is on my grid, which would be right there. 0, 1. Forgot to label my vertex again. That's -2, -3. All right, so I'm going to flip it 2 this way. So I'm going to go 2 this way. That looks like the point 1, 2, 3, 4 left, up 1. So that's the point -4, 1. So we get an idea of what this graph is doing. Highlight the axis of symmetry there so you can see it a little bit better. Okay, when x is equal to 1, I have 1 plus 2 squared minus 3, which would be 3 squared minus 3, which would be 9 minus 3, which would be 6. So I have the point 1, 6. Okay, 1 right, up 6. Okay, and then this is 3 units to the right, so I'm going to flip it and go 1, 2, 3 to the left. That looks like the point -5, 6, 5 left and 6 up. So you get a better idea now of what my parabola is doing. Okay, so to recap, your A, okay, your A value, that stays the same. That determines up and down and wide and skinny. Okay, your vertex is h, k. Just remember, when your h is a positive, you actually have to make it a negative. I know that sounds weird. Okay, your vertex is also going to tell you the axis of symmetry, and then you're going to pick 2 x values to find. Try and find the neatest possible x's you can to make your life easy. You only have to be careful when you have fractions. Okay, and then you use your 2 new points and flip them over and find 2 other points, and you got yourself a u.